Okay, welcome to River City Ransom Underground. My name is Andrew Russell. I'm the lead programmer on River City Ransom Underground, and today, so in the last two episodes, we had a little look at, first of all, loop recording, and then we had a look at move replacement. And there's something else that I wanted to show off that sort of involves moves and sort of involves the loop recorder. And this is something that I kind of thought I originally wouldn't do, but this is a feature that's sort of half finished. And I was thinking I'd mostly talk about stuff that we've actually finished. But I've been working on some of the stuff to do with how moves are stored and the system for that. And we have something called a move table. And one of the things I've been messing around with is, can we do some kind of automated testing on that move table? And one of the things we can do is we can automatically spit out a whole bunch of loops. And in fact, if I close Excel, because it will complain about the file being open, I can actually show you how fast this is. I'm only doing I think 4 characters here, because I've set it up to be a little bit faster for development, but let's do it anyway. So it's on the AI developer keys and test. So, it takes, I don't know, less than a second, and it spits out this. And so I'll just bring that onto screen. And so we've got Alex, and we have, the characters, and we have a whole lot of moves for Alex, and a whole lot of moves for Glenn, and Mike, and then Fat Mike. So what these are, each individual file is a loop recording. So if I were to, for example, let's grab Glenn Airborne. So this is the initial state for move testing with Glenn, and he's airborne. So you can see I drag that loop in, and oh yeah, these loops are a fixed length, so I can just keep playing it with the button. And then if I bring in grapple back for Glenn, so that's the initial conditions for a grapple move. Glenn on the ground, Glenn running is not going to be very interesting because he stops running with nothing else to do. Glenn with a weapon in his hand. So these are all the initial states. So we generate, the point is we are generating these and spitting out loops, and we do that in the background in the game. And the idea is we can test moves in a sort of automated fashion, because we have, I know that there's 50 move tables in the game, and I believe there's something like 500 moves in the game. That's a lot of moves to sort of think about and test. And so anything we can do to sort of automate that process is good. So what I'm bringing up here is a little comma-separated value file that the engine spits out for testing. And you can see this is the one for Glenn. So this is Glenn's move table. So you can see he's got 64 moves, some of which are duplicates because they have different preconditions. For instance, there's 2 different ways to do kick, toss, forward. And each move has some flags. So this one's a special move that happens on the ground, and it has an unlock index, so you can unlock it. There's a special move that comes from move 28, so you have to do palm thrust and then groggy punch. So that's one of the nice things we do in the engine. I'm not set up to demo this maybe I can. Maybe I can. So I wasn't planning to do this, but I will bring in Glenn. Here we go, because this is the wonderful thing, is I can bring in Glenn Full Nelson, and I can just get Glenn out of that state by waiting. So, oh no, this is a problem. So there's a bug, and that bug is that they're on the same input channel. I don't know why that is, but the point is, if I punch Alex and I punch him again, you'll see he does a different punch move until he ends up there. And he only does that every time he hits Alex. Whereas, now this is the tricky bit, if I bring in Glenn grounded, and you know, I keep mashing punch, he's not hitting anything, so he keeps doing the same punch move. So that's just a little gameplay thing that we do. We have a sequence of moves. So there's different ways to get into groggy punch. So this one comes from 23. So you can see left jab goes to left jab, goes to double kick, goes to cross punch. So, oh, actually there's two different paths here. So from left jab to double kick state, or from left jab to cross punch state. So these all come from move 21. So I want to show you this because this is like the way the move system is set up to operate. But over here on the right hand, these ones, and we can see we've got a failure there. This is the automated testing. So if I bring up move 0 for Glenn, so that's hip toss forward. So, and because the engine has spat out these loops automatically, I can just drag it in. If I'm like, does hip toss forward state work? Let's find out. We'll drag it in. Oh, and it does. And you know, I can do that thing I did before. I can show the moves, the states, so we can be extra sure. But I don't have to test that one because I can see that it matches. Whereas here's a move crowd surfing. So I know for a fact that the reason that move 38, crowd surfing state, fails is because it actually requires another character in there to work. So this move has a move condition and it's failed the condition, so it has failed. So and then it's ended up in idle state. Whereas this one, blustery kick, we tried to do the blustery kick, and that's the way we ended up. We got blustery kicks. So I'll show you. This is the wonderful thing about the loop recording is I can replay the data that was used to generate this. So there we go. There's blustery kick. And so we see we tried to do a bluster kick and we did a bluster kick because it checked what state it ended up in, and you know it's in the blustery kick state. So that's a match. Whereas this one, we tried to get into the crowd surfing state and we failed the condition, and we ended up in the idle state instead, and it didn't match. So these ones here, right now we don't test that damage thing I was showing off. You have to damage someone to actually continue in the sequence of moves. So we didn't get into these later ones. So we might add that later. We will see whether that's actually a worthwhile thing to spend time on. A lot of the idea of doing this was making sure the AI can do all of the moves. And so, you know, all of these ones that match just directly are pretty trivial for the AI, whereas some of the ones that have a move condition, you know, maybe we need to add in some special consideration. But this is a slightly different system to the AI, so it's up in the air whether it's actually worth making all of these work automatically. But making them work, you know, being able to do that. So as I was saying, we have over 500 moves in the game. Being able to say, well, all of these ones work, this one doesn't, so we'll manually test this one, and we'll manually test these ones, but these ones that match, we don't have to pay quite so much attention to those ones. So, you know, it's kind of like a way of doing unit testing. Anyway, the thing is, we can do this for all the characters. So there's Glenn and then Alex, you know, because it's comma separated values, all these columns are tiny. But, you know, Alex has these moves, and you know, I've used this for debugging, like, you know, why is a move not working? I could go to the code for the move table. So in fact, let's show off some of the internals. Let's heroes Glenn. So there's his move indices, which is used for unlocking. But here's his move table. So we're adding all of this to the move table. So the first thing that gets added is hip toss forward, and the flags are grapple front. A few flags get added automatically, but we can go back here, we can look what did the move table actually end up being. Hip toss forward is the first one, yeah, so hip toss forward, and it's a standard move and it's grapple front. So you start in the grapple front state and you go. So the test thing would have gone in, it would have grabbed Glenn grapple front, so that's where we're testing from. It would have grabbed that, and then it would have done move 0, and it would have attempted to do that. And this is all running off player input. So does this? Yeah, it does too. So I can actually bring this up. You can see, because it's automatically generated, it's just blinking those ever so briefly. So so you can see on frame 0, they blink up there and then go away immediately, which is enough for the move system to work. So there you go. So there's sort of this really interesting thing we can do with loop recording, is we can actually generate these loops in the background. Like we don't have to render these as we generate them, and we can just spit out a whole lot of stuff and investigate what happens to the simulation, because because it's a networked game, the whole thing is set up so that the simulation can run updates independently of the actual game running, which is handy. So yeah, thanks for watching, and as usual over here we have follow me on YouTube, Twitter @_Andrew Russell, or andrewrussell.net. Thanks for watching, and I'll see you next time.